we are working with mass spring system. So we have this system, mass M, spring with constant K, the external force F. F is, in this example, I do for odd function, a period to L. And we solve for xt. So given the input function F, the force, we need to compute the response, the xt. We need to compute function xt. So this is a non-homogeneous system. So we have xt equal to h represent for the homogeneous one, if this one is 0, plus x particular. So for homogeneous part, the complementary solution is given by this. For the particular solution, I do the sp, steady periodic function, and we use Fourier series to solve for xsp. So we write down Fourier series of f, we compute that explicitly. Given a force f, we can compute the Fourier series of f. And the particular solution here, x steady periodic function, is given by this one under the condition that omega naught is different from n pi l for all n. So omega naught is the natural frequencies of the system, square root of k over m. So we need this condition for all n greater than equal to 1, so that we can do this division, so that this denominator is non-zero. If the denominator is 0, we cannot do that. This one becomes very, very big when this one tends to 0. So in that case, we have resonance. And now we consider that. And let's consider the pure resonance case. Pure resonance. So in this case, because of the superposition principle, I don't need to compute the whole thing. I don't need to consider the whole Fourier series of f. Let's just look at the part where we have the resonance. So look at the case where we have a natural number n, so that this one equal to the natural frequencies. So now we consider the case where there exists a natural number n, so that big N pi over L equal to omega naught. And look at the equation mx double prime kx equal to, so we have here for the force, we can write down as Fourier series summation bn sine n pi t over L. Now I don't want the other part for any other n. I just look at the n where we have big N here. Look at small n equal to big N. Look at the pure resonant part. So we have bn sine n pi t over L. bn sine n pi t over L. So n pi over L, n pi over L is omega naught. So we can write down as bn sine omega naught t. Mx double prime kx equal to bn sine omega naught t. Now we need to find a particular solution for that. Find xp t. Satisfy this equation. And we know that for the homogeneous part, we only have cosine and sine. So we don't want just cosine and sine, so now we need to go a bit further. T times a cosine omega naught t, b sine omega naught t. and you do x double prime. So you take this one double prime plus k times x equal to this one, and you solve it. And you substitute in, say, star. Plug in star, and you solve for the coefficient. You will get xpt will then be minus bn over 2 times m omega naught t cosine omega naught t. So this is our particular solution in the case we have pure resonance. So instead of having these terms for the solution of this system, now we write out the solution, the corresponding solution. Of mx double prime kx equal to ft, which then becomes when resonance occurs. xt become this part when n equal to big N, and plus the summation when it is not equal to big N, and plus this summation. So for all n different from big N, so Bn we computed before. Bn is given by this one. So I can plug in there. Bn equal to this part. So the solution is of this form. When resonance occurs, this means that when we have this condition, when there exists big N, so that this equal to omega naught. Omega naught natural frequencies. So omega naught here equal to square root k over m. So for exercise, for example, they could ask us to check if resonance occurs or not. Then you would check whether there exists a natural number n, so that this one equal to the natural frequencies. And as you see that the terms, these terms grow unboundedly with t. So that's why when resonance occurs, it can lead, mathematically, it lead to the system break. Like we have the bridge, and if the wind or the sound term matches on the bridge, when we have the frequencies equal to the natural frequencies, the bridge can collapse because of that.